Hello everyone, today I'm going to be helping you model an assignment in SAP. This assignment here, help you model it in SAP. Okay, you can hit new model or Control N. Hit Control N, make sure your units are in kips, feet, Fahrenheit, like in the assignment, kips, feet. Okay, hit the grid. For this, we're gonna put these grid lines up on this assignment to make it more visually pleasing, I guess you could say. In the X, we have 1, 2, 3 grid lines crossing the X. And in the Z, 1, 2, 3 grid lines crossing the Z axis. The Z axis is the axis of gravity, the up and down. So we have 3. Y is going into the screen. We have 1. And then the Z, we have 3. For the spacing, we can put 7 feet in the X direction, and we could put 7 feet in the X direction. Doesn't matter, we'll edit it later. So in the X direction, we have 7. The Y direction, we have 1. The Z direction, we have 7. Okay. Go right here to XZ view. XZ view. Next, you can double click the grid to start editing the grid. It's default to ordinates. This is the absolute distance. From origin, I like using the spacing better. In the Z, in the X direction, from A to B, it's already at 7. And from B to C, it's at 7. But we need it to be 15. So this one edited to 15. In the Z direction, we have the first spacing is 7. The second spacing is 18. So we can edit this one to 18. Let's hit OK. Hit the full screen, restore full view on both. Okay, now to double check your measurements, go to draw frame cable and click here. That's 7. And this is 7. Hit escape, click here. Click this grid point and hover over. It's 15. And this is 25. Total length is 7. Hit here. This is 18. Okay. So the grid matches the assignment. Okay, next, go to define your material. You can edit this material, you can add your own. I'm just gonna edit this one. This is the unit weight, make it 0. Hit OK. OK. Next, define the section properties. I like to add my own section. Go to other, general. All this is okay. Hit okay. This part, set modifiers, make the weight 0. This is the material we edited earlier. And change the name to something like F2. Just recognizable for you to make sure this is the one you created. Let me just double check the weight. This is all okay. By the way, this is where you can change the moment of inertia for any section if you need to change it to match a problem or its density. Oh no, I'm sorry, not this one. The density was in this one. Okay, this is all okay. Okay, and okay. But define the load patterns. We have dead load. Set the self weight multiplier to 0. Hit modify. Create another one. I have load. Tab over. Hit L. Hit add. New load. Then we create the wind load. Tab over. Hit W. This pattern automatically populated. Well, it will skew your calculations. So just put it as none. Add new load. And these loads match the ones in the assignment. You're giving dead load, live load, and you're giving wind. Okay, load created. Okay, next you're going to define a load pattern, or I mean a load case. I'm going to add a new load case. We're going to add, we're going to rename it. Okay, we're going to rename it to this. Okay, we're going to add this dead load as 1.2. Add the live load as 1.6. Add, then the wind load 0.5. Add. Okay, everything else is okay. Okay. So we define material, we define section, we define load patterns, we created a load case. All that's left now is to draw the frame. You can draw right here with the quick draw frame cable. All the way across. Hit escape. One more time. Here to here. Escape. Now this is a good catch and a good self-check. Go here to this little check mark box. Go to frame, hit section, hit apply. Notice this is FSEC1. This is not the member I created. So we need to change it to the member that I created. So click it, right click, double click section property, F2. Okay, update display. Notice F2 is now created. Can do this for this one as well. I'm sorry, update, okay. This one, right click, double click, F2, okay. Update display. F2 is now can modify. Now this one. Click, right click, double click, F2. Okay, update display. Okay. Now, the restraints, drag from left to right. Assign joints, restraints. Go with fixed. Okay. Now is a good time to save. I already created this one earlier. Save it there. Now to add the loads, click this. You can click here, highlight it, right click, loads, assign loads, distributed, dead load, absolute. The dead load was 45, right? 45 dead, 100 live, and 5 kips. 45 dead load. Okay. We can assign another load since it's highlighted. Assign distributed. Now we make it live load. Make it 100. Absolute. Okay. Notice now you have dead load 45, live load 100. Update display. Okay. For the win, click the joint. You can right click it if you want, or you can go to assign. Go to load joint forces. Since it's going in the left direction, it's -5 kips. Don't forget to change it to wind. Hit apply. And okay, notice it's here. You could also assign the distributed load through assign frame loads distributed. They'll give you the same, you end up at the same table. Save it. Okay, now to display all the loads on the table, you can go to object, load on the frames, do global, apply. Well, this is only showing the dead. This is a good check, dead load, live load, and then you have the wind. It's a joint force, so you gotta go to display, object, joint, show the wind, hit apply, and there's the wind. Another neat trick is go to display, show load case tree, click this load combination that you created, show loads, and there's all the loads. They overlap because they're over the same section, but I assure you this is 45 and 100 overlap. Okay, save it again. This little box here toggles it to shrink the objects. Click this, everything is shrunk. You can hit F5 to run the analysis. Okay, I don't want to run everything, I just want to run the load case I created. Run now. So the deform shape. Okay. Click this box. Click here, show forces and stress, or you could hit F8. F8 will bring you to this box. You could put axial forces, show value. Don't forget to toggle shrink, so that way it's clearer to see. Shear to 2, apply, shows you the shear, the moment, it's the moment. Show the reactions. So you go here, joints, F8, or, sorry, is it F8? No, F8 is for the stress. Go here, go to joints. The tabulated one will show you the reactions at the supports. The arrow as well, to show you the axial and shear. It doesn't have the moment. The tabulated one has the moment. Okay. This is also a neat little table that SAP gives you. Show deformed shape. Go to draw contours on objects and the wireframe, the wire shadow. This is okay. We'll just check this. This is deformation in the X in the horizontal direction. Apply. Notice the darker color, purple, is experiencing the most horizontal displacement. In the Z direction, looks like this part vertically is experiencing the most deformation. Okay, this is negative 2.8 times 10 to the negative 3. This is what that E means in the scale for distinguishing the color patterns. I'll show you in the Y. There's no deformation in the Y. 0. It's not bending forward. It's only going horizontally and downwards. So we are looking at the X. This is what we have. All of this horizontally deformed. So now to show you the table, you can do Control T, or you can just go to here to display. Control T is right. I like Control T. Control T will show me displacements, reactions, the frame output. This is the only load case I want to see. Let's go to the joints, displacement, click here to have the highest value. Joint 2 is experiencing the most X displacement, X, Y, and Z. Let's go joint 2. Okay. Let's set up the labels for the joints. Joint labels and frame sections. Apply to all windows. Okay. Where's my sections? Show the form shape. There it is. And this one will show as over here. Okay. So what did Control T, Control T, Everything's highlighted as previous. Displacements. Here you are. The max was joint 2. Joint 2 is experiencing the most horizontal deformation. X, Y is experiencing nothing, and this is the Z. The Z is experiencing at joint 1. This is vertically. Here at joint 1 is most displacement here. Is joint 1 vertically, and horizontally is at 2. The reactions we saw earlier, you go to F8, or not F8, you go here to joint, you go here, joints, tabulated, give you the reactions. Control T, everything's the same, nothing's changed. Here's a little tidbit for you. Notice this is frame 1, and it's giving every station a certain increment. You can change the increment to be every foot, starting from station 1 at 0 feet from here, on that way a foot. So you can unlock it. Highlight everything. Go to assign frame output station, maximum spacing 1 foot. That's every 1 foot. You're gonna get that on the table. Hit apply. Hit OK. Messed up the name a little bit, but it's okay. Hit F5. Run it. Hit Control T. The same as previous. Hit OK. Now you have outputs for every foot on the frame. And also the graphs for the moments are more continuous. I guess you could say more smooth. They're not jagged by 2 feet. Now they're every 1 foot. And it's smooth and continuous. It gives a better looking graph. More accurate data if you need that specific foot, every foot, or you can right click here. It'll show you. You can scroll through it. Where is it at 0? But this is scrolling. You could even edit it to be 0.1 foot. Oh, it's got to be unlocked to do it. I hope this helps you. Thank you.